Hello everyone. I'm really glad to see so many people who are interested in performance, optimization, maybe a little bit in performance testing too. Yeah, you know that, performance testing, performance optimization without testing, it's a pretty strange activity. And first question to warm up, maybe somebody knows. I know that one person in the room knows what is it. Alex, previous speaker. But maybe someone else knows what is it. Oh, it's flame graph, yeah. So I'm sit down because for me it would be much convenient to see what is it happens on the screen. Actually, I'm backend engineer with pretty good experience, and I'm going to talk about performance testing and optimizations of your APIs, and web services. This speech will be interesting for backend engineers, QA engineers, solution architects. I hope almost for any engineer. Okay, here is the agenda. I'll tell you about value of performance testing, how to explain this value to other engineers and to business people, and also a little bit about methodology, how to do it properly. I'll give you advice about toolbox, some tools, how to do it, and also talk a little bit about performance monitoring of your pipeline and continuous performance. And I'll show a little cute demo. A couple of words about me. I'm a backend engineer with 12 plus years experience. I implemented different types of services. It was game servers, web services, game platform, and much more. And I always try to create software which responds before receiving the request. It's very difficult, almost impossible. And always interested in performance optimizations and how to do properly performance tests and apply to your project to achieve the great results. And here is the mascot. It's performance warrior as AI looks into it, I generate. So let's go. And ultimate questions for performance tests is, why do we need performance tests? Because it's a difficult question. Just for some reason, people don't do it. Engineers may say that I'm a strong engineer, can write a fast code straight away. Moreover, it's not my job. QA engineers should do it or something like this. And business people could say that you have to work on business features. We can't afford any distraction performance tests and optimizations. It's a pretty common question and answer from business. By the way, business may say that you should write your code as fast as possible without any special activity. You are a really great specialist, professional, and receive a lot of money. So I will try to answer this question, and let's start from some examples. Case 1, 1 terabyte RAM consumption. Once upon a time, one game development company decided to conquer the world, definitely globally with passion. And among other activities, they decided to develop some pretty cute currency service with interesting non-functional requirements. This service should handle more than 50,000 requests per second with latency less than 100 milliseconds and 10 million concurrent users. It was pretty impressive requirements for developer who was responsible for this project. So the developer decided to create a prototype and to use Erlang in this prototype because 10 million CCU was was pretty tough requirement for Python stack which used in this company widely. And after developing prototype, the team, the manager ordered servers and 3 servers with 300 gigabytes of RAM. Not so big setup, but enough for that reason. And run simulations just to check that the prototype meets the requirements. The architecture is cool enough. It's good approach. And everything was okay after night simulation, but Erlang cluster consumed about 1 terabyte of RAM. It was a problem, and DBA, which is in this team, said, "Are you crazy? Please give this RAM to PostgreSQL and will they achieve the light speed." So definitely this issue was fixed after this test, and don't occur in the production, but it was interesting. Reaction to see reaction, and good case to mention. Second case was preparing as a game platform for New Year event. So once upon a time, the same game development company, decided to sell loot boxes with some Christmas gifts, New Year gifts to players, and players were really happy to buy all these gifts. And after releasing this New Year shop, they started to buy these gifts with very significant very quickly. I mean, it was a very popular lot, and usual load to this shop was about 1 request per second, and then engineers and managers saw like more than 1,000 requests per second, and realized that they neglected performance testing, and they develop only features, and nobody knows how it works and how much it can proceed. So actually it was interesting case from point of view of business too. It looks like a truck with money decided to put your money into bank account, but you receive 503 on this request. One more truck of money, more 503. So and from point of view of engineers, it was a sprint, 30 hours sprint of non-stop in hot fixing, convulsive optimization. Like you need to do it, need to fix everything which neglected during some long period. And fortunately, it was a happy story. Finally, all players pay all money they want, maybe a little less, who knows, but in general it was a very successful event, and the company decided to do some preparation in advance and started to prepare to New Year in advance in February. I mean, in February of this year. And the next New Year was pretty good from point of view of performance and user experience. It was about 30-second hiccup of the shop, and nothing else happened. Just everyone was happy. And definitely performance tests may help you to fix much more issues in your application. And it may be missing indexes in PostgreSQL table. You just unable to see it via your functional tests. Some deadlocks, leaking connections, and also memory leaks. Even you can find some issues in open source libraries, for example, Erlang Prometheus library. I hope that person who found this issue is already in this room. Maybe we can discuss it later. And definitely some application settings may be wrong, like pool size, or maybe your balancer may be configured not so suboptimally, like in Nginx. I can continue. Its slides is pretty reduced. I have a lot of examples. So here is the value of performance tests. For engineers, it's valuable. You can uncover reliability and resilience issues of your system. And correctness of your system will be increased if you fix issues which you found. Definitely you will understand performance of your system, how it works under load, and you can plan measurable optimizations and then recheck that optimization help. And definitely also you will know consumption of resources of your application, and then understand, maybe optimize these resources or just plan capacity if you have hardware. And engineers understand the code infrastructure better after this activity. It's really, really valuable. And for business point of view, performance tests are even more valuable as I see. Because you will have happier users who enjoy the service and recommend the service to other users. It's really important. You will not, from business point of view, you will spend less money on your infrastructure, and you don't lose a lot of money in case of hardware failures, downtimes, poor performance. You're ready for that. For these events, performance tests may help. And also in some cases, high performance may be a major competitive edge or advantage. So the slide may be used by engineers to explain valuable of these tests to business. And how to do it? How to do performance testing? I was a hot engineer who trying to apply some tests to any service which I develop. So I use usually this methodology, fire and the motion, in 2 words. Like here is 4 points, like how to do it together with performance testing. And like take any performance tool which you like or you want. Choose some scenarios. It may be pink from the start, but it's better to choose some business endpoint, like this endpoint with business logic, and write load script if needed. Some tools don't require scripts. Some tools are requiring to write some logic, and run this tool and see what happened. Like visit, inspect the tool output, system resources usage, application logs. You will almost certainly find something interesting. This approach is also okay if you're testing prototypes for solution architects. It's really, really important to test your solutions as early as possible. Okay, but if you're going to know how is your system behaves in real environment, as I should mention, it's good enough for local deployments. Usually, but it's not enough to real deployments of application. By the way, I have a question to you. Please raise the hand. People who use performance testing in their project, some approach, maybe fast approach or maybe some complicated. Oh, that's great. Thank you. It's just boxes. They may look simple, but we will discuss each box separately. You should prepare for testing, and then you execute this test, analyze results. And here you have a cycle. When you analyze results, you may decide what to do next. Maybe you should fix the code of your application. Maybe you should fix the tests. Sometimes tests are broken. And this cycle provides the value if you like spend some time here. You have enough resources for that. Sometimes you need to design some other tests because you know more about tests or you receive some extra input from business. And please don't forget to write a report for you and for your colleagues. It's very important. Some people are lazy, but it's really important. What about test preparation step? It's really important to prepare for your test. It's good. Good strategy here is to ask questions. You should ask questions to the business about the requirements, mostly about non-functional requirements, about reliability, performance. Sometimes business can't answer. You should create by themselves such requirements and make an agreement with business, like explain what is it, and so on. And definitely you should understand where is your system is deployed, and deployment should be made before performance tests. And it's good idea to understand the main common scenarios, majority of users, how a system was used. Sometimes it's easy to answer, sometimes not. It's a good idea to tell a little bit about peak loads. So for example, do you have any Black Friday events or something like this with peak loads? How much time and money do we have for performance tests? Because the budget is really important. If you have just a few days, it's one test. If you have enough resources, it may be different situation. And yeah, definitely also it's a good idea to talk about some problematic critical cases from point of view of business. They should be tested first. Okay, here is a stage. Write down all these answers. You will have some understanding how should you perform your tests. Prepare your dedicated test environment and deploy application to it. Maybe you can reuse your original test environments, but it's not recommended approach because you need a lot of resources. Often it would be not so cheap to have one environment for every task. And then you choose scenarios for performance testing and pick some tool and code these scenarios for choosing tool. Sometimes you may code generate these scenarios using AI or just do some recording. But sometimes you should code. It depends on the tool. Also, you should decide about the load profile, how much load for each API you will send, or to each page in case of web application. What is the load pattern? It's a stable load or increasing load, or maybe it's a burst if you want to simulate some black market scenario. And don't forget to load initial data into your database if you have some database, because testing on empty database, it's not don't show you real results for your application, because your production load usually have data in your database, and sometimes you can copy this production data set, sometimes not. It depends. Okay, and after preparation, we are going to execute the tests. So it's a good idea to debug and develop tests locally on small amount of level of concurrency. But it's really important. Don't try running your performance workload from your laptop. It's better idea. Please use special node or special container near to your infrastructure. You should warm up your system before sending the full load, or just ignore the first part of your test. I will show you later how it looks like. Definitely, you should monitor the system performance and resource usage in real time, and I'll show you how to do it. The holy grail of any QA is finding the saturation point. What is it? I will explain later. You should run tests at least 10 minutes. It's better to run 30-minute tests or 1 hour and more, just to show, just to understand how it works because you usually have long-running application, long-running services, and short tests don't show you the big picture, how it is. So here is actually basic slide, which it's really important. How to find saturation point. It's one of the main approach. You just send some load, and this load is increasing, and see how your system behaves. And you actually the basic 3 metrics to monitor. It's the number of successfully handled requests, the number of failures, and the response time or latency. Depends on the behavior of your application. You may have different pictures. This is example slide with highlighting these zones. Here we have warm-up zone, your application just, doing some JIT compilation, or just starting some connection to database in connection pool, it's called. And when you add some load, you will see that latency have become stable, and we'll add more load and we receive more awk requests, and it's a normal load zone actually. And at some point you may see that the latency started to increase, and the number of successfully handled requests is stable. It's actually a stress zone, and the saturation point, it's point which divides two zones, like normal load zone and stress zone. And actually, this point is very important, because you may understand how much load you may handle in this environment with this application settings and code, and then maybe configure your rate limiting or something like this, because we don't want to see and to handle requests with higher latency. So at some point, if load increasing, the latency may be too high, and the application started to generate some errors, and you'll see that number of errors is increasing, and number of successful requests is decreasing. And if your application is not ready for such load, it may fail at all and stop processing any requests. So here is the basic how it works. And after performing tests, it's a variable workload test. It's time to analyze test results. Actually, I think analysis of performance testing, it's pretty creative process. Sometimes you don't know what's going on. You don't know what issue contains in your code or settings. You should dive into logs, dive into the metrics, and the basic principle is just compare actual results with expectations. Sometimes expectations, everything is okay, you don't expect much from your application, and let's stop. But actually, it's often also, even you have everything okay with expectation, you may find some errors, you may find some anomalies in metrics. And so because of that, it's very important to visualizing all the metrics, including performance metrics, application metrics, infrastructure metrics. Okay. Definitely, if you play the role of performance QA, it's a good idea to make a demo with all the results to developer. If it is you in the role of both roles, it will just to maybe just to take a break and review all the results. And a good tactical move is in some complex cases, gather all involved people, because sometimes you have different microservices, different teams which are responsible, and each service performed well alone in isolation, but if you put it into a system, it works not so well. So if you gather such people into one room or into one call and analyze together and run performance tests together, it's really good approach. And definitely don't forget to write the final report, because maybe you should repeat your tests later. And for deep analysis, you may try to use methodology from Brandon Gregg. It's about resources, more about more about Linux kernel, but it may be used for analysis your web application or API. But it's definitely separate speech about how to apply properly this methodology. But in one sentence, you should understand what resources you have in your system and check each resources how it's utilized, and if resources utilized well or overutilized, it's a problem. It's errors, it's also a problem. Please read by the link. Presentation will be available later. Okay, a couple of word optimization. I'm not a fan of optimization To be honest, I like reasonable optimization. If we see real value from optimization, we should perform it, because you may break some functionality when you optimize it. So, but if you decided to do it, please do it wisely. Good tactic: change one settings, one piece of code, and repeat the test and see how it works. Maybe your guess was wrong. I prefer to use scientific method, like having some hypothesis and experimentally prove or reject this hypothesis. And definitely visualizing your system on a board is a good idea. You may do it together with colleagues, but learning internals of system, for example, learning something about PostgreSQL if you have problem with database, or about RabbitMQ, it's really valuable exercise. If you still don't understand the problem, try to add metrics or logs and repeat the test. Maybe you'll find something interesting in logs or metrics. And yeah, here is some algorithm how to choose the proper tool for your performance test. I provide such algorithm, like try to use Locust, WorkAid2 or JMeter if they are key for you. If they are not okay by some reason, take the most convenient tool from the list, Awesome Performance Testing. Unfortunately, I don't own this list, but maybe I'll try to gather my own list. But it's great. And by sometimes you have some exotic requirements, custom protocol, and you have to develop your own test. It happens. By the way, one question is, does anyone use any of these tools, Locust, WorkAid, or JMeter? Oh, that's great. Thank you. We will discuss it, how it is. Okay, a couple of words about WorkAid2 and WorkAid. It's a simple console tool in C, and it allows to write a script logic in Lua. I'm not a fan of Lua, but it's pretty interesting language for this use case. And you can generate 1 million of RPS on local machine. I did it on some machine to Nginx. It was not my API, but through loopback. So it's a pretty nice tool. It's like a hammer. You may kill almost each service except Nginx, maybe. It's small amount of resources, and it's under the hood. It uses LuaJIT and a loop from Redis. So WorkAid2 is just a fork which has a nice features like constant throughput and which in more accurate latency. Locust, it's a great tool in Python. It's very powerful for complex workloads. If you have some scenario which has complex logic, you may simulate different behaviors of different users and log in, log out, and so on and so forth. And you write just plain old Python code, but it scales. You may scale it both vertically and horizontally. It has handy web UI, a really nice tool. I recommend it. And JMeter, it's a default tool if you don't like WorkAid2 or Locust. QA engineers like this tool very much because it don't require any coding. You may just click your workload using the graphic user interface, or you may record some requests in proxy mode and apply and then replay this activity and doing it very effectively. Especially good for legacy web application, which has a lot of work, lots of scenarios, difficult to code, and yeah, very stable, active in development with really regular fixes. But it's pretty a lot of resources. And here is a comparison slide. So if you need light speed, so please choose WorkAid2. It's good for developers, but QA engineers also may use it. Locust is for end-to-end testing, and it's very handsome. And also you can run locust using PyPy and use JIT for Python. And using PyPy, you can generate much more load, like 10 more load in the same resources. Gmeter, it's also nice tool. They all have some drawbacks. For Gmeter, locust is RAM and CPU consumption. And Gmeter also has ugly reports. Sometimes they may have issues, but I should be ready. But you know that locust fix a lot of issues in past 2 years. It's really impressive work in upstream. Okay. For Verka, you can see results in real time. Difficult to see any good reports. Difficult to monitor. Okay, here is some notes about monitoring and continuous performance tests. Definitely, we all know that monitoring is important, and we monitor our services using different approach. Somebody use cloud native tools, somebody may use Zabbix or Prometheus or whatever you like. But if you do performance tests, it's also very important to monitor all components of your system and also monitor your performance test generator, because it may have some problems with performance because it's generate a lot of load and it may be bottleneck by itself. So it's a really good idea to gather all interesting key metrics into one dashboard. It makes test analysis much more insightful and simple. I'll see how this dashboard may look like. And some semi-final step, it's running your performance test in pipeline, for example, in Jenkins, similar to functional tests, and to run it regularly and analyze regular results. But the final step, it looks like a separate project, is run fully automated performance testing pipeline with automatic analysis of results, automatic deployment. I won't tell you a lot about this. It's a separate speech, maybe, a separate project. And here is an example how the solution might be look for Locust and Prometheus. You have application which has connected to a database, like web application, for example, and you generate load using Locust. And applications and queries to database. And we see some results of work, but we don't understand how it works. But we can add monitoring. Prometheus start pulling metrics from application. We can integrate application. Also, we can integrate Locust with Prometheus with a little effort. And we may use Grafana for visualization such metrics. Also we can add metrics exporter to our database, for example, a PostgreSQL exporter or Redis exporter or whatever. And if you have EC2 virtual machines hardware, you can add node exporter into this solution and see how your hardware behaves or how your EC2 instance behaves, like low-level metrics, receive low-level metrics. And it's time for a little demo. Let's try Locust and Workey in action. Okay. Oh, here's the cat. He said, let's perf test. Okay. I tried to do it. It was difficult. Actually, we will run our perf test against this simple inventory service. It may be service for some game development company which has to implement distributed inventory, like storing information about people, I don't know, weapon or other items in the game. So it has a Swagger UI, so it seems to be working. Yeah, and now, okay, I'll tell you a couple subnets. Okay, here is the console. Now it's the most problematic part of my speech. it was disconnected from the SSH when we okay. Actually, yeah. Compose. Oh. Yeah, here you can see Docker Compose with deployment of all mentioned services. It was inventory service with database. It is Postgres in this case, Prometheus, Grafana, and some other services. I don't recommend to use Docker Compose for production deployments. So, but it's easy to try. So I prepare this mostly for demo purposes. So we'll see that it is working. Let's try to do some perf testing using Locust. Yeah, this is UI Locust. We specify the number of users and the spawn rate. So spawn rate and target. I specify here an internal name of the service because of Docker Compose, but let's start. Okay, it started to generate some load. It's mixed workload, 2 APIs for getting and changing this inventory. Yeah, and here we can see some chart. Yeah, the latency starts maybe a little bit more, but then it's stabilized, so it's like warm up. And then, yeah, when here started to add some amount of users per second. So I specify 10 users per second. And see, and also we can monitor our workload using Grafana dashboard. Yeah. Here is how it looks like from Locust point of view. So it just you may ask why we need Grafana if we have such great UI, but actually Grafana is just visualization of time series in Prometheus. It's database which store for pretty long time, for half a year if you want, or you may store different test runs and compare them using this approach. And also, this graphs exist only in this Locust. So, yeah, you can see that something bad has happened. Latency started to increase on the lot of not so big workload, 400 requests per second. And the same we can see this one. Also, we can see from the point of view of our service, it's metrics which are taken from our service. So we see the same picture. No errors still, but the latency is increasing. And here we can see the saturation point actually. It's our here. So we have maybe here. Sometimes it's difficult to find it exactly, but it may be a range of some workload. But here we started to increase the latency, but here the latency is increased significantly. The stress is pretty. So we have some bottleneck. I definitely know what is the bottleneck because I created it by myself, but finding it in a real application may be not so easy. So I will show you this bottleneck. Yeah, it just doing some calculation in one of the methods, and it's interesting that it affects not only this method. It's grant item, so it affects all methods in this worker. So let's try to fix it and see what happened. Hope that it helps. Oh, here we have to see how the failure may look like. So the number of errors has increased. Yeah, by some reason the number of OK requests is also not fallen to 0, but maybe it's an issue in locust. So, but now we can see that, yeah, we handle more requests. And also I should mention that, we can add some interesting metrics from different point of views. Sometimes we may have to inspect CPU usage on a node, or maybe CPU usage of each process. But in most cases, we need at least repairs, latency, and errors, and you will see this in locust and in Grafana. Actually, data source is Prometheus. Yeah, here also some exceptions in locust and some information about these test runs. You may use it as a almost ready reports to your tests, and just attach them some screenshots and this information about the test to the Jira ticket, for example, and bingo, you'll have a report. Okay, I also want to share that you may find great dashboards about your node. It's dashboard is not created by me. Grafana has its own great set of dashboards. It's always a problem for the backend engineers to create great visualization. For me, it's like a salvation to find such dashboards. For example, for monitoring your hardware, node exporter. For monitoring PostgreSQL, you may use PostgreSQL dashboard. And you may find it on Grafana site. Okay, you may Google it. And yeah, here. Okay, the final step of my demo is showing how ORK looks like. Let me see. I'll stop the demo. I'll stop the load from a locust and just run ORK. It's not so scary. Like if you know Python, it's not so scary. Just some script, one more script language, and let's run also mixed workload. Yeah, here you just run the command line tool and send some params to it using command line and environment variables. So we have 100,000 users here, request per second 1,000, and duration 30 seconds. So, and let's see. Yeah, by default you don't have any monitoring with, and you may use some Hotop or some other tools, or you may use your own Grafana dashboard, also together with VRK. And also, I should also mention that you may use both tools. Sometimes it's you have some complex workload. I also have some extra workloads like black market, and VRK is very good on hammering services. So, like locusts don't have any workload, but if you see its inventory, see the spike of load, it's 30 seconds test. Okay, that's it probably. And disclaimer, don't run performance tests without agreement of the service owner. It may be interpreted as denial of service attack. Please don't do it. If you own your service, it's okay. Here is some final thoughts. I think I just repeat some theses that performance testing is really valuable activity and exercise for many businesses. And I hope that managers of long-running IT projects has to think about performance, not only about business features. And non-functional requirements are very important, especially performance, probably because I'm a performance enthusiast. My recommendation is the same, like VRK2 for tests with simple logic and stress tests, Locus for simulation with complex logic, Geometry for some other cases. And I think that running performance tests on your services and APIs may be really funny and valuable exercise. Don't leave such a fun to performance testers on anyone. Please try to do it by yourself. It's really great activity. So come to the perf test site. And yeah, let's go and try to perf your API. Any questions?